The United States is actively incorporating new technologies into the printing process of the American dollar, utilizing advanced yet cost-effective robotic machines. These machines perform complex tasks previously handled by highly skilled specialists, reducing maintenance costs. The production of dollar banknotes in the U.S. is a sophisticated, high-tech, and tightly regulated process. Each banknote undergoes numerous stages, from preparing the special paper to packaging the finished bills for distribution. The paper used for dollars is unique, composed of 75% cotton and 25% linen, giving the banknotes durability and their distinctive texture. During production, red and blue security fibers, watermarks, and a security thread visible under light are embedded in the paper. The printing process begins with offset printing, where a base background and decorative elements are applied. Offset machines operate at high speed, processing thousands of sheets simultaneously. The next stage is intaglio printing, which creates raised images like presidential portraits and denominations, producing a textured surface easily recognizable by touch. Screen printing follows, applying special color-shifting inks that change hue depending on the viewing angle. This feature is particularly prominent on $100 bills, where the denomination shimmers between copper and green, providing an added layer of anti-counterfeiting protection. After the primary printing stages, serial numbers are added. Each bill receives a unique identifier along with other details, such as Federal Reserve Bank numbers. Banknotes then undergo stringent quality checks. Automated systems equipped with high-resolution cameras inspect each note for defects like misaligned prints, blurred lines, or incorrect colors. Sheets containing defects are automatically rejected and destroyed. Then, large sheets containing 32 banknotes are cut into individual bills. The finished banknotes are sorted, bundled into stacks of 100, and sent to storage facilities for later distribution to banks through the Federal Reserve System. Robots play a crucial role at every stage of production. They operate printing machines, managing ink supply, pressure, and precision in image application. Robotic systems handle the transportation of raw materials, paper, and finished banknotes between production stages, minimizing the risk of damage. Additionally, automated quality control systems equipped with cameras and sensors instantly detect any defects. Robots also participate in the final sorting and packaging of bills, preparing them for shipment. Dollar production is a well-coordinated and meticulously planned process that combines skilled expertise, innovative technologies, and multi-layered security measures. Through stringent oversight and robotic integration, every banknote meets the highest standards of quality and security. European countries are also adopting cutting-edge technologies to print billions of high-quality banknotes. The process of printing euro banknotes is a complex and high-tech operation that involves several stages, from design development to the distribution of finished currency. It begins with the design, created by the European Central Bank in collaboration with the national central banks of the Eurozone. The design must be both visually appealing and incorporate advanced security features to prevent counterfeiting. Production starts with offset printing, where the primary images and backgrounds are applied to special paper. This step ensures high precision and quality. The next phase is intaglio, or engraved printing, which adds embossed elements such as portraits, architectural motifs, and denominations. These features give the banknotes their characteristic texture, making them difficult to replicate. Simultaneously, security elements are incorporated into the banknotes. These include watermarks visible when held up to the light, security threads embedded in the paper, microprinting with fine text visible only under magnification, and holograms that change appearance based on the viewing angle. These features make counterfeiting euro banknotes extremely challenging. After printing, each batch of banknotes undergoes rigorous quality control. Automated systems equipped with high-resolution cameras and sensors inspect every banknote for compliance with size, color, and the placement of security elements. Banknotes with even minor defects are automatically discarded and destroyed. Robots play a critical role at every stage of euro production. They automate numerous processes, such as managing printing machines, transporting materials, ensuring quality control, and handling packaging. For example, robotic systems ensure even ink application, precise alignment of printing plates, and the swift and careful transport of paper, ink, and finished banknotes between production stages. Cameras and sensors integrated into the robots detect even the smallest defects, ensuring the highest quality of finished products. The use of robotics makes the banknote printing process more efficient, reduces human error, and minimizes costs. This ensures that every euro printed meets strict quality and security standards, which is essential for maintaining trust in the currency on an international level. The process of gold mining and the production of gold bars is a complex, multi-stage procedure requiring advanced technology, meticulous oversight, and the use of robotic technologies. It begins with gold extraction, which can be conducted either through open-pit mining or underground mining. In open-pit mines, surface layers of soil and rock are removed to expose gold-bearing ore, while in underground mines, tunnels are created to access deeper deposits. At this stage, robots are extensively used for exploration, mapping, and monitoring equipment operations, enhancing safety and efficiency. Once extracted, the gold-bearing ore undergoes enrichment. It is crushed and ground into a fine powder, after which methods such as gravity separation, flotation, or cyanidation are used to separate gold from other minerals. Modern enrichment plants employ automated systems and robots to regulate processing speed and accuracy, making the process more efficient. The next stage is refining, where impurities are removed from the gold concentrate obtained during enrichment. Gold is dissolved in acids and then precipitated back to pure metal. Refining achieves a high degree of purity, up to 99.99%. Many refineries utilize robotic systems for precise chemical dosing and process monitoring. After purification, the metal moves to the melting stage. Gold is heated to its melting point, approximately 1064 degrees Celsius, in specialized induction or gas furnaces. The molten metal is poured into molds, where it cools and solidifies into bars. There are two main methods for producing bars: casting and minting. Casting produces traditional bars with uneven surfaces, while minting ensures smoothness and precise dimensions, essential for standardized investment-grade bars. Robots manage furnaces and transport molten metal during this phase, improving safety and precision. Once the bars are ready, they are marked with details such as weight, fineness, manufacturer's logo, and a unique serial number. The bars are then subjected to quality control to ensure compliance with international standards. Robotic manipulators and sensory systems are actively employed to scan surfaces and verify weight accuracy. In the final stage, the bars are packaged in protective materials to prevent damage and oxidation before being shipped to storage facilities or clients. Robots play a significant role in the automated packaging and sorting of bars, ensuring their integrity during transportation. Thus, the production of gold bars is a process that combines centuries-old traditions with cutting-edge technology. Robotics is integral at every step from extraction to packaging, enabling high precision, efficiency, and safety.